Welcome to this lesson on metals. In this presentation, we will explore the physical and chemical properties of metals and their everyday uses. By the end, you will understand how metals differ from non-metals and why certain metals are chosen for specific purposes. Metals are one of the most important groups of elements in chemistry. They make up around 3/4 of all the elements in the periodic table. Metals are part of our everyday lives, in buildings, vehicles, machines, electrical wiring, and even cooking utensils. Metals are held together by metallic bonding. This means positive metal ions are arranged in a regular lattice, surrounded by a sea of delocalized electrons. The strong attraction between the ions and electrons explains why metals are strong, conduct electricity, and can be bent or shaped. If you would like a full explanation with animations on metallic bonding, click the link in the top right corner of this video to watch the complete lesson. Let us begin with the physical properties of metals. Metals are known for their ability to conduct heat very well. For example, cooking pans are usually made of metals because they transfer heat quickly from the stove to the food. Another important property is electrical conductivity. Metals allow electricity to flow easily, which is why they are used in electrical wiring. Remember that this is one of the main reasons copper is chosen for household wiring. Metals are also malleable and ductile. Malleable means they can be hammered or rolled into thin sheets. Ductile means they can be drawn into wires without breaking. This makes metals very versatile in construction and industry. Finally, most metals have high melting points and boiling points. This means they remain solid at high temperatures, making them useful in building materials and machinery. Note, exceptions exist, for example mercury, which is a liquid at room temperature. Now, let us compare metals with non-metals. Non-metals are usually poor conductors of heat and electricity. They are brittle, meaning they break easily when hammered. Most also have low melting and boiling points. This contrast helps us clearly distinguish between metals and non-metals in exams. When metals react with dilute acids, they form a salt and hydrogen gas. For example, when magnesium reacts with hydrochloric acid, magnesium chloride and hydrogen are produced. You can observe fizzing and heat. To test for hydrogen, bring a lit splint near the gas, it makes a pop sound. Exam tip: do not confuse hydrogen gas with oxygen. The pop test is the best way to confirm hydrogen. Some reactive metals, like sodium, react with cold water to form hydrogen gas and a metal hydroxide. For instance, sodium plus water gives sodium hydroxide and hydrogen gas. Less reactive metals, such as magnesium, only react with steam, not cold water. They produce a metal oxide and hydrogen. Remember, sodium reacts violently with cold water, but magnesium needs steam for reaction. When metals react with oxygen, they form metal oxides. For example, magnesium burns with a bright white flame in oxygen to form magnesium oxide. This shows metals are reactive with gases in the air. Now let us discuss the uses of metals. Aluminium is widely used. Its low density makes it ideal for aircraft. The same low density and good electrical conductivity make it suitable for overhead electrical cables. Aluminium is also resistant to corrosion, which is why it is used in food containers. Copper is another important metal. It is used in electrical wiring because it is an excellent conductor of electricity and is ductile. This means it can be stretched into thin wires without breaking, while still carrying electric current effectively. Now let's look at corrosion. Corrosion is when metals are gradually worn away by reactions with substances in the environment. For iron and steel, this process is called rusting. Rusting needs both oxygen and water to occur. The product is hydrated iron 3 oxide, which appears as a reddish-brown flaky solid. Rusting can be prevented using barrier methods such as painting, greasing, or coating with plastic. Note: do not write that rust is iron oxide. The correct name is hydrated iron 3 oxide. Many students lose marks here. Another important method of protection is galvanizing. This involves coating iron with a layer of zinc. The zinc provides a barrier to stop water and oxygen from reaching the iron. But even if the zinc layer is scratched, the iron is still protected. This is because zinc is more reactive than iron and loses electrons more easily. In other words, zinc undergoes sacrificial protection by corroding in place of the iron. Exam tip: when asked about galvanizing, always include both the barrier effect and sacrificial protection. Students often mention just one and lose a mark. Let us look at an exam-style questions. In this question you are asked to name the type of bonding in the elements, state the test for hydrogen gas, suggest the pH of a solution of a strong alkali, name a substance which can be used to confirm the pH of a solution of a strong alkali, write the symbol equation for the reaction between sodium and cold water. You can pause the video to give it a try. Here are the answer to the questions. Let's take a moment to test your understanding of what we've covered so far. Please choose the correct answers to the following questions. You can pause the video if you need more time and also re-watch to answer the questions. Thank you for learning with AceStudents. If you found this lesson helpful, be sure to check out our playlist for more videos. Every video includes evaluation questions to help you test your understanding. Our content is perfect for homeschooling, Google Classrooms, or private tutoring. Don't forget to subscribe and click the notification bell so you never miss a new science lesson.